Chapter 1: Oscillatory Motion. Oscillatory motion is the to and fro motion of an object from its mean position. Examples of oscillatory motions. 1. Oscillation of simple pendulum. 2. Spring movements. 3. Vibrating of strings in musical instruments. 4. Alternate current. Periodic motions. Periodic motions is a motion of an object that regularly repeats to a given position after fixed time interval. Examples of periodic motion are motion of hands of the clock, motion of planets around the sun, etc. Oscillatory motion is a type of periodic motion. Frequency and period of periodic motion. Frequency, F, is the number of cycles made in 1 second. The SI unit of frequency is called Hertz, Hz. Period, T, is the time taken to make one complete cycle. SI unit of period is seconds. Simple harmonic motion, SHM, is a type of motion under the influence of restoring force described by the Hooke's law. Restoring force is force which acts to bring a body to its equilibrium position. In other words, examples of simple harmonic motion. 1. Simple pendulum. 2. Mass spring system. 3. A swing. 4. A steel ball rolling in a curved dish. 5. A steel ruler clamped to a bench oscillates when its free end is displaced sideways. Hooke's law states that the restoring force applied by a spring is proportional to the displacement of the spring and opposite in direction. Terms used to describe SHM. 1. Displacement, x, is the change in position of an object measured from its equilibrium position. 2. Amplitude, a, is the magnitude of the maximum displacement or the maximum distance of an object its equilibrium position. Angular frequency, omega, is angular displacement per unit time. Its unit is radian per second, rad/s. The force constant is measure of rigidity, stiffness, of the spring. We see the higher the spring constant K, the stiffer the spring and the greater the angular frequency oscillation. A smaller mass will also increase the angular frequency for a particular spring. Note: 1. The period of SHM depends on the mass of the vibrating body and the force constant of the spring and is independent from the amplitude of the motion. 2. Frequency of a SHM is only dependent on the mass of the object and the force constant of the spring.